Okay, so for this lecture, we're going to focus on writing chemical formulas of binary ionic compounds. So when we speak about binary ionic compounds will always contain two elements only. Two elements. So that will contain one monoatomic cation. So mono means one. So I just want to emphasize that mono means one, but monoatomic automatically means one type of cation, one element, one atom that becomes a cation, and another, so another plus one monoatomic anion. Okay? So it's a partnership between one cation and one anion that contains only one specific type of atom. So let me give you a representation of this monoatomic cation and anion. Let me make use of some algebraic symbols. Remember the x and y? I'm going to use x and y here. So every time you have binary ionic, you always begin with your cation positive. So let's say my positive is x, element x. And the charge of element x is 2 plus. So I write x. So x can be any symbol of any cation element. Then the charge is 2 plus. The second one is an anion. So let's say it's a y. Okay? Y. And because it's an anion, the charge should be negative. And let's say, for example, that the charge of y is 1 negative. Okay? And remember, 1 negative can be written as negative as well, because 1 may not necessarily be written. And most of the time in chemistry, if it's a 1, you don't have to write the 1, just write the symbol. So negative means the numerical value of that is 1. If it's also a positive only here, then that means 1. But if it's not a 1, of course, you have to write the number. Same as this one, 2 plus. So that means the charge is really 2. Okay. So how do we write the process of chemical formula writing between a monoatomic cation and a monoatomic anion? So let me show you how. The process is what we call a Criss-Cross method. Criss-Cross method. So what's a crisscross? You know that a crisscross is like a cross, a X. Okay? So this is simply the way to do the crisscrossing. Encircle the numerical value of your charge or oxidation number of the cation first, and then it will go to the subscript, to the bottom right of the anion element here. Okay, so the 2 will transfer here to the bottom right of y. And then here for the negative, I'll just encircle that, but that means 1. That means 1. And it will go to x as a subscript of x. So basically, crisscross is switching over the numerical values of the oxidation numbers and make them as a subscript of the other element. So when we write this down, so let's write that down. What's the outcome of this particular crisscrossing of x and y? So the outcome will be x will have, remember the value of this is a 1, right? So x will have a subscript of 1. So simply I write down the symbol of x. The subscript is a 1. So I'll put 1 there. Okay? Let me just put the 1. But later on you will see that it will not, it shouldn't be there because it's just a 1. So x will have a 1. Okay? And then for the y, let me write down the symbol again. Of course, you have to write the symbol. The y, remember the 2? It went to the y. So the 2 will become the subscript of y. And when we crisscross in the final chemical formula, you do not have to write the positive and the negative symbols anymore. There's no more positive and negative. You discard them. You ignore them. So the crisscrossing is focusing only on the numerical values. The switching over of the numerical values and putting those numbers as a subscript. And if it is a 1, you may erase that because 1, it's understood to be nothing. So the result chemical formula for X2 plus and Y negative is XY2. Okay? Now, I'll put this in context. So let me put, I hope that you have written this down on your notebook. Please. Okay, so let's have examples of real elements this time. So when we have real elements, let's go back to our periodic table chart. Okay? When we had a periodic table chart, remember that I let you copy this chart before? That will give us the charges. Remember the oxidation numbers per group number of the representative elements. Representative meaning the first 2 columns here and the last 6 columns here. It's easy to remember the oxidation numbers because we know that group 1 is 1 plus all the time, group 2 is 2 plus, and then group 13, everything here is 3 plus. The 1 in the middle can be 4 plus or 4 minus, but if you notice, I didn't highlight that because we don't really use group 14 for ionic, so you may just ignore that. That won't be given as examples most of the time for ionic, so that's why don't bother yourself with the 1 in the middle. So after the middle group 15, after group 14, the group 15, that's the start of the minus. And you should begin with 3 minus because that's 3 columns away from the noble gas. So that's why it's 3 minus. That was the concept of that. And then group 16 is 2 minus. And then the second to the last column is 1 minus because that's the one closest to the noble gas. Just one more. So that's why it's 1 minus. So these ones that I highlighted, these are in your chart. And we will be using this to crisscross our oxidation numbers. Okay? So let's begin. Let me have, for my cation, let me have magnesium. Okay? So let me write that down. Magnesium is my cation. So Mg. And Mg is found in group 2 and the charge is 2 plus. So the charge is 2 plus. I put that on top as a superscript. Okay? So if you're doing it raw, this is not yet the chemical formula. We're still having it as an ionic format. So if it's an ionic format, the charges have to be written as a superscript, top right. The number first, usually followed by the sign. So this is your raw ion, not yet the chemical formula. And then I'll partner it with oxygen. Okay, O, group 16, so 2 minus. Okay, so O, 2 minus. I'll put them side by side. Okay, so these are my pair now of cation and anion. So let's do now the crisscrossing. So remember, when we crisscross, we have to only focus on the numerical value and we ignore those charges already. And then we drag them. The numerical value will become the subscript of the other element. And same thing with the non-metal here, the negative will go to the metal here as a subscript. So that's our crisscrossing. And then after we figure out that, we can now write the numbers as a subscript. So the Mg will have a 2 here as a subscript, no sign, and then the oxygen here will also have a 2 as a subscript. If you notice, the subscript that we see have the same value. And this is what you need to remember in ionic compounds. The subscript should just represent the ratio of the elements, the ratio. So if the number is the same, you have to express it in lowest terms. So basically, if the number is the same, 2 and 2, that's going to be reduced to 2 and 2, that's going to be reduced to what? Reduction in math. When we simplify, that will be reduced to 1, right? 2 and 2 are both divisible by 2. So by reducing it or simplifying it, the 2 and the 2 can be reduced to a 1. So therefore, the final outcome of Mg2O2 can be rewritten as simply Mg capital O, because that was reduced to a 1. So the final answer for Mg2 plus and O2 negative pairing will be MgO. So when you write this down on your notebook as an example, take note, put a reminder to yourself that if the numerical value of the ones you're crisscrossing are the same, you have to reduce it to 1. And that is one of the rules in crisscrossing, writing chemical formulas of ionic compounds. Let's go to example number 2. So for example number 2, I want to use K, potassium, and K is group 1. The charge is 1 plus. So K 1 plus, or written simply as a plus because it's a 1. So just put it as a plus. And then I want to pair it up with S, sulfur, group 16, 2 minus. So S 2 minus. Okay? 2 minus. Now let's do the crisscrossing. Very easy. Just make sure that you know the values. Okay? So if it's a 1, I'll just encircle the plus. That's understood to be 1. And then I encircle 2. And then I drag down the numerical values as a subscript to the other element. So I will do that. You really don't have to show the arrows. If you can do it mentally, then that will be great. The more, that's going to be faster for you. So I'm just putting these arrows for representation purposes, but later on when you get to be fast with this, it can be done mentally and just write the chemical formula right away. Okay? So finally, when we do this, the 2 will be here and the 1 will be here. So the final answer for this is K. Make sure it's capitalized. And then the 2 is dragged down as a subscript. So that should be a little number there, bottom to the right. And then capital letter S. And it's a 1. So I don't need to write the 1. 2 and a 1. Of course, we can't simplify it anymore. It's a 2 and a 1. So therefore, this is our final answer. I'm sorry, the 2 got covered. There you go. So that's the final chemical formula for the pairing of K and S. Okay, third example this time. Number 3. Example number 3. I'm going to use aluminum, Al, and the charge is 3 plus. Okay, Al here, 3 plus. So I'm going to write it down. Al. L should be small letter because that's the second letter after capital letter A. So do not make a mistake to capitalize your L there. Okay, it's a small letter L. That's not letter I. That's letter L. Okay, big letter I has 2 lines up and down, horizontal lines. If it doesn't appear that way, it's small letter L. So Al 3 plus. And I'll pair it up with fluorine, F. Fluorine, F, the charge is 1 minus. So F minus. Okay, F minus. No need to put the 1 there. Now, I will pause for a while and I need you to write it down on your own. What's the resulting chemical formula between Al and F when put together? Therefore, mentally, you know that the 3 will go to F and the 1 here for F will go to Al, and so the resulting chemical formula is Al F subscript 3. I know in the chat you cannot put a subscript 3. It's a big 3 right there, but when you write it by hand, make sure that you write it as a clear subscript.